Alright, welcome to Forces and Equilibrium, first lesson, Components and Forces. First of all, you need to understand something. Suppose I have a force F. Force is a vector quantity. So force has two things. One is a magnitude, the other is a direction. So suppose I say that this red color is a force F and the magnitude of F is 10 Newton. This is the magnitude. But what about direction? If I am as the direction of F, I can say that F is 30 degree from the horizontal. What do I mean by that? You see, this force F makes an angle theta from the ground, and theta is 30 degrees suppose. So I can say that F is 30 degree from the ground when referring to the direction. Alternatively, I can also say, for example, that F is 60 degree from the vertical. If I have a vertical reference, for example, suppose that this is a vertical line, and I can say that this angle is 60 degree because if it is 30 and this should be 60. So I can also say that F is 60 degree from the vertical. This is very important to understand because you will be having questions where they will ask you to find the magnitude and the direction of forces. So it's pretty important that these things are clear to you. Alright, so let's get started on the component of forces. Let me just remove these things. So suppose that I have a block. I have a block in here and I will be applying a force of suppose 10 Newton to this block. Let's write this as F and let's say that F is 10 Newton. So actually this F is made out of two components. What do I mean by components? Let's forget this F for a moment. Suppose this block is 5 Newton. The weight of this block is 5 Newton. And if I put a force of suppose 10 Newton, F is 10 Newton, right? If I put a force of 10 Newton, where does the block go? It moves up, right? Okay, pretty simple. But what if I put a force in this direction and say that this is F? F is 10 newtons and suppose that there is no friction. The block moves this side, right? But suppose I'm adding another force to this direction. Let me just change the color. Suppose that there is another force which is 5 Newton. So first it was 10 Newton F and now we have another 5 Newton. So it will be 15 Newtons to the right. Am I right? Yeah, pretty simple. But how about if I say that we have a force of 10 Newton this direction and we have a force of 10 Newton this direction. 10 Newton on the 10 Newton on the vertical and 10 Newton on the horizontal. What about that? Which way will be the resultant force? Because we have 10 Newton upwards and 10 Newtons on the right. In this situation, the force will be somewhere in this direction. Now you might say that what will be the magnitude of this force? Definitely we don't know. We need to find out. Let's see how we will find out. So basically, if I clear all this and make it simple, let me just clear all this up so that you can understand better. Suppose I have a ground again. Suppose this is a ground and the force I'm talking about is this one, 10 Newton this direction and 10 Newton on this direction. Okay, and if you see that let me write 10 Newton. um, Let me take some more space. 10 Newton, and this is also 10 Newton, right? So if we want to find the resultant, let's see. As I said that the resultant will be somewhere here, right? Okay, what if we draw a straight line here? Suppose I'm drawing, okay, this is a bit short, so suppose I'm drawing a straight line here. So now I can say that this horizontal force is 10 Newton, and the this vertical force is also 10 Newton, right? And I need to find out this resultant force. How can I find the resultant force? Let me draw the resultant force on a different color. I think that will be better for understanding. Suppose this is the resultant force. So how will I be able to find the resultant force? Basically using Pythagoras we can find it, because you see this is 10 Newton and this is 10 Newton, and we need to find this one. So if we say that this is F, we can write that F square equals to 10 square plus 10 square. And we know that if we solve it, it will be F equals to root 200 Newton, right? Alright. Now if I am asked to find the direction of this F, how can I find it? So suppose this angle is theta, and I need to find this angle, right? We talked before the video that if we want to find the direction, we say that it is suppose theta degree from the horizontal, or suppose it is alpha degree from the vertical. So let's say we will find the direction from the horizontal. So it's pretty easy to find theta, right? We know this one is 10, this one is 10. So definitely the diagram is not okay. The values will be wrong, but you get the point, right? To find the theta, we need to write, suppose, sine theta. So it's opposite by hypotenuse. So we can use cos here. Adjacent by hypotenuse, or we can also use tan, right? Tan theta, opposite by adjacent. So here we can write that tan theta equals to the vertical component and the horizontal component. So we can say that 10 by 10, which will not give a right value definitely, because this theta won't be a value that will be correct because I just drew it, but you understand, right, how to find theta? Alright, just to make things much more simple, let's think something like this. I'll remove all this, and I'll remove this, I'll remove this. Suppose I have a force F, and forget about these are in force. Think of them as axis. This is the y-axis, and this is the x-axis. And I have a force F. So this force F has two components, right? It has a vertical component and it has a horizontal component. So how do we find out the components? Let's see. Suppose F is 10 Newton again. So I'll say that F equals to 10 Newton, and I will say that theta equals to 40 degree, for example, in this case. So basically it's the same. We can use trigonometry where we can draw a straight line here, suppose, and then we can use the trigonometry to find it. This is F 10 Newton, this is 40 degree, and to find the horizontal component we can use trigonometry, so we will use cos, right? So we know that cos theta, suppose cos theta equals to adjacent by hypotenuse. So we are finding the adjacent force, which is the horizontal force. So let's write horizontal force, horizontal force, horizontal force, and let's say that this is F, right? Cos is adjacent by hypotenuse, and we know that force is 10 Newton. And bingo, we found theta. It's as easy as that, but we don't need to find theta, right? We know theta, so we put in the value of theta here, and we can find the horizontal force easily. Same goes for the vertical force. So if we want to find this vertical force here, suppose this is the vertical force, and we know that we can use sine theta, right? Because sine theta is opposite, which is the vertical force, by hypotenuse, which is F, that is 10 Newton. So I can simply remove this and write here sine theta, and I can remove this from here and say that this is the vertical force. As simple as that. So now we know that sine theta equals to vertical force by 10 Newton. To make things easier, you can use a different method. A shortcut, I would say, but you understand the thing, right? That how to find this. So basically, a little bit shortcut is that if you are asked to find the horizontal component, for example, and you know that you know the angle from the force to the horizontal ground, you can basically write, suppose this is horizontal force, I will write HF. You can simply do this, that horizontal force equals to F, the force we were using, F cos theta. And if you are asked to find the vertical force, we can say the vertical force equals to F sine theta. This is a shortcut, and you can just directly write this to make your calculations easier. However, remember that this shortcut or this thing or formula we have here is for when the theta is with the ground. But what about if this is the theta? If this is theta, then things change, right? So if this is theta, the things will be opposite. So the force we are finding, which is with the ground, in this case, suppose vertical force, this is the vertical force, right? So this vertical force, the angle from the vertical force to the force we are finding is cos theta. So in this case, I will say that F cos theta equals to the vertical force, and for the horizontal force I will say that it is F sin theta. Now you might be a bit confused that why are these things like this, and can't you just do the trigonometry? Yes, you can. The trigonometry is the base of these formulas. If you solve them by trigonometry, you will see that you will end up with these formulas. However, this will speed you up. I mean, you do not have to think in a trigonometric way every time you attempt a math. So it's better to know how we find it. But yes, that's it. So for practicing right now, you need to know a couple of things I would ask you to practice. The first thing is finding components of forces. So suppose this is the ground and I have a force in this direction. So we know that this force has two components, right? It has a vertical component and a horizontal component. So basically what you will do is that you will find the horizontal component and the vertical component of this force. This will help you to practice so that you do not get stuck when we go to complicated maths. Suppose this is 60°. So I will have a couple of exercises in this chapter, and you will complete each and every one of them and see if you understand. The questions are automatically checked, so I don't think it will be a problem. Please be reminded that these are not from past papers, and these are for practice only. So I guess that if you practice a little bit and understand the concept, it will not be that hard. Thank you so much.